Hi dear students, welcome to Gita's classes. In this class, we are going to see some evaluation of some integrals using Laplace transform. So in the previous classes, we have seen how to find out the Laplace transform of the elementary functions, and please try to remember all these functions, Laplace transform of elementary functions. And we have seen first shifting theorem, that is if the function is multiplied by e power at or e power minus at, without e power at you have to find out the Laplace transform and replace s by s minus a or s plus a accordingly. Similarly, if it is multiplied by t power n, always remember for multiplication try to relate with differentiation and division integration. Okay. So if it is multiplied by t power n, then you have to differentiate, find without t power n, you find the Laplace transform and differentiate n times with respect to s. Similarly, if it is divided by t, then without divided by t, the functions for the function, you find the Laplace transform and integrate from s to infinity. And next we have also seen Laplace transform of derivatives, L of f dash of t, f dash of t. Try to remember these formulas so that it will be useful for our solution of, when we are finding the solution of the differential equations, it is going to be very useful. Similarly, Laplace transform of integrals we have seen, that is without integrals you have to find out the Laplace transform, that is f bar of s, and just divide it by s. Similarly, twice the integral means 1 by s squared. 3 times if you have integral 0 to t, then 1 by s cube and so on. Okay. Now we are going to evaluate some integrals. Evaluate the following integrals using Laplace transform. Whenever it is given like this, try to relate this with L of f of t. What is L of f of t? By definition, integral 0 to infinity e power minus st f of t dt. Okay. This is our Laplace transform definition. So whenever it is evaluated, asked for evaluation using Laplace transform, try to relate it with this e power minus st f of t dt. And please remember one more important point is the limit should be 0 to infinity. Then only we can use this. Okay, we can use Laplace transform. So this is equal to, I am going to write this as integral 0 to infinity e power minus st into t dt at the point s is equal to, here in the place of s, 3 I have written s. So I have to replace it by 3, right? So integral 0 to infinity e power minus st t dt in which s can be replaced by 3. So try to write e power, whatever is there, you write it as e power minus st, and in the place of s you have to remember. Okay, this is how you have to proceed. And this is equal to, what is this by definition? It is L of t. We know that the definition of L of t is integral 0 to infinity e power minus st. This function is t dt, right? So at which s is equal to 3. So what is L of t? 1 by s squared, at which s is equal to 3. That is 1 by 3 squared, that is 1 by 9. This is the integration value. Okay. Next is integral 0 to minus 4t, 0 to infinity e power minus 4t sine 3t dt. So this can be written as integral 0 to infinity e power minus st into sine 3t dt. When you are writing e power minus st, why are you writing like that? We have to relate it to Laplace transform. So Laplace transform definition is e power minus st into f of t dt, right? So this is equal to, at the point, now s is equal to 4. So you have to replace s by 4. In the place of 4 only we have written generalized form s. So s should be replaced by 4. Okay. So integral 0 to infinity e power minus st 3t dt is what? L of, by definition it is L of sine 3t. Okay, at s is equal to 4, which is equal to L of sine 3t is what? A by s squared plus a squared. So here a is 3 here. So 3 by s squared plus 3 squared, that is 9. At the point s is equal to 4. That is L of, sorry, integral of, not L of, integral of 0 to infinity e power minus 4t sin 3t dt is equal to 3 by s squared plus 9, in which s should be replaced by 4, right? So this is equal to 3 by, that is in this, wherever you have s, replace it by 4. So 4 squared plus 9, that is 3 by 16 plus 9, that is 3 by 25 is the answer. Next is integral 0 to infinity sine 2t by t. See, I told you when you are using Laplace transform, try to relate it with integral 0 to infinity e power minus st f of t dt. So in the previous problems we had e power something, e power minus 4t, and before that e power minus 3t, like that we had. So here we don't have now, so what to do? Just write it as 0. So this is equal to integral 0 to infinity. Can I write it like this? E power minus st into sine 2t by t dt at s is equal to 0. So when you substitute s is equal to 0, what will happen? E power 0, which will become 1. So this 1 into, in the place of 1 I am writing it as e power minus st, where s is equal to 0. Okay. So this is equal to, by definition, what is this? L of sine 2t by t at s is equal to 0. What is L of sine 2t by t? Division means integration. So without this t you find the Laplace transform, integrate from s to infinity. So integral s to infinity L of sine 2t into ds. After finding this, it will become a function of s. So this is at the point s is equal to 0. That is integral s to infinity L of sine 2t. So 2 divided by s squared plus 2 squared, that is 4 into ds. At the point s is equal to 0. So what is this? Integral s to infinity. So 2 I can take it outside. What is this? 1 by integral of 1 by s squared plus 4 squared? 1 by 2 into tan inverse of s by 2 from s to infinity at the point s is equal to 0. So this 2 and 2 will get cancelled. Tan inverse of infinity minus tan inverse of s by 2 at the point s is equal to 0. That is tan inverse of infinity is pi by 2 minus tan inverse of s by 2 at s is equal to 0. So pi by 2 will be as it is, minus tan inverse of s is what? 0. You have to substitute s is equal to 0. So tan inverse of 0, which is 0. Therefore the answer is pi by 2. Okay. So this evaluation of integral, that is integral 0 to infinity sine 2t by t dt is equal to pi by 2. Next question, integral 0 to infinity t into e power minus t sine t dt. So again you write it as e power integral 0 to infinity e power minus st into t sine t dt at the point s is equal to, in the place of a, what do you have? E power minus st. In the place of s, what do you have? 1. So s is equal to 1. So integral 0 to infinity e power minus, what is this? L of t sin t. By definition, L of t sin t at the point s is equal to 1. Now it is multiplied by t means minus d by ds of, without t find the Laplace transform, that is L of sin t, and differentiate with respect to s once, because it is t multiplied by t at the point s is equal to 1. That is minus d by ds of, what is L of sin t? 1 by s squared plus 1 at s is equal to 1. Okay. So that is equal to minus of d by ds of 1 by s squared plus 1. So it is minus 1 by s squared plus 1 the whole square into 2s. at the point s is equal to 1. Okay, you have to differentiate 1 by s squared plus 1 with respect to s. So minus minus will become plus. So 2s divided by s squared plus 1 the whole squared at s is equal to 1. That is 2 into 1 divided by s is equal to 1 means 1 plus 1 the whole squared. That is 2 by 4, which is 1 by 2. Okay. Next is show that t squared into e power minus 4t sine 2t dt is equal to 11 by 500. So now we are going to compare the left hand side integral with Laplace transform, that is equal to. Now let us consider the left hand side. So LHS integral 0 to infinity t squared into e power minus 4t sine 2t dt is equal to integral 0 to infinity e power minus st into t squared sine 2t dt at the point s is equal to, in the place of s what do you have? 4. S is equal to 4. It is not minus 4. We have already the formula is e power minus st only. Here you have e power minus 4t. So s is equal to 4. That is L of t squared into sine t at s is equal to 4. Right? That is minus 1 the whole squared into d squared by ds squared. Because it is multiplied by t squared into L of sine t. So without that you find out, differentiate. Then s is equal to 4. That is minus 1 the whole squared is plus 1. So d by ds of, once let us differentiate this, what is that? L of sine t. Okay. D squared by, first let us write L of sine t is 1 by s squared plus L of sine, sine 2t. Sorry. Here this is sine 2t. So what is L of sine 2t? It is 2 by s squared plus 2 squared, that is 4 at the point s is equal to 4. Which is d by ds of, now differentiate this, 2 I can take it outside. So minus 1 by s squared plus 4 the whole squared into 2s, right? At the point s is equal to 4. This 2 also I will take it outside. So 4 into d by ds of, minus 4 into d by ds of s by s squared plus 4 the whole squared at s is equal to 4. That is minus 4 into, now you have numerator also s, denominator also function of s, therefore u by v form. So in the denominator s squared plus 4 the whole squared, right, into v squared, then v into, so s squared plus 1, sorry, here the whole power 4. Because you have already square, again square it, v squared, so s squared plus 4 the whole power 4. So s squared plus v into, so s squared plus 1 the s squared plus 4 the whole squared into du, that is 1, minus s into, now differentiate this, so 2 into s squared plus 4 into 2s. You have in the denominator s squared plus 4 the whole squared. Okay. At the point s is equal to 4. That is minus 4 by s squared plus 4 the whole power 4 into, now you observe this numerator, here you have in the first term we have s squared plus 4 the whole squared, and second term also I have one s squared plus 4. So I am going to take it outside. Okay, so s squared plus 4, 1 s squared plus 4 I am taking it outside. So after that what will happen? In the first term I have s squared plus 4 the whole squared into 1. Here s squared plus 4 the whole into 1. So 1 s squared plus 4 I have taken outside. So remaining is s squared plus 4 for the first term. And in the second term you have 2s here, 2s here. Here 2s and 2s, 1 s squared plus 4 has come out. Okay. So 4 s squared minus 4s squared. So that is equal to minus 4. Here 1s squared plus 4 and this one will get cancelled. This will become s squared plus 4 the whole cube. Into s squared plus 4 minus 4s squared. So 4 minus 3s squared. Or you can say 3s squared minus 4 divided by 4 into 3s squared minus 4 divided by s squared plus 4 the whole cube, right? That is equal to 4 into for everything you have to write s is equal to 4 at the point s is equal to 4. Here also at s is equal to 4. So now in the place of s you substitute 4. So 3 into s squared, that is 16 minus 4 divided by 16 plus 4 the whole cube. That is 4 into 48 minus 4. So that is 44 divided by 16 plus 4. So 20 into 20 into 20. So that it will be easy for simplification. This will be 5 and 44. 4 means 11, again 5, right? So it will be 11 divided by 5 5 are 25, 25 into 250, so 500, 11 by 500. This is what you have to prove, right? 11 by 500 we got. Okay, this is the answer. So using Laplace transform, if you want to evaluate the integrals, you have to write it in terms of integral. You compare it with e power minus s, integral 0 to infinity e power minus st f of t dt. Okay. Then according to the value of s, whatever is required, according to that you replace s. And please share it with your friends and give a like. And please share it with your friends so that it will be useful for them. Okay. Thank you so much for listening.